Hey Finxter, Pandas is Excel on steroids, and the powerful Python library allows you to analyze structured and tabular data with surprising efficiency and ease. And Pandas is one of those reasons why master coders reach 100x efficiency in comparison to average coders. And as Bill Gates said, a great Lethe operator cannot be like 2 times, 3 times more efficient than the average Lethe operator, but a great coder can be 10,000 times as efficient and productive as the average coder. And one of those reasons why the excellent coders is much more efficient, much more productive, is because of their great use of libraries. And the Pandas library is a very powerful friend on your path towards data science mastery. And in this video we are going to look at how to work with missing data in Pandas, in particular how to handle none values, not number values in Pandas DataFrames. So none values arise if there is no data, if you load a data frame and some cells are missing basically. And so first of all, I will cover simply different kinds of problems, and I will discuss the problems as I go along so that you will get an intuitive understanding of how to handle missing data in Pandas. So have a look at the following code. I just copy paste this code here. So you first import Pandas, you also use NumPy. By the way, if you're interested in NumPy, then check out our book, Coffee Break NumPy. It's a great book to improve your data science understanding. We are currently in the process of writing another book, Coffee Break Pandas. So stay tuned, subscribe to our email list or our channel. I give links in the description below, and you can check out both books, NumPy and Pandas books, to improve your skills in the data science area. Good. So back to the code. We have a data. We create a variable data and we initialize it with a series. Series is just that, a one-dimensional series of elements, and you use a list to initialize this. And you use the not a number value, np.none. So not a number value is a constant of the NumPy library. In this case, Pandas is built on the NumPy library, and therefore it's very important that you understand the NumPy library well before you go into Pandas. And I mean, even you can go into Pandas, but then you need to over time and gradually build your NumPy skills. And we have a lot of NumPy tutorials and courses in our free email academy. You can subscribe below. It's not only for Finxter Premium member, but also for all Finxter members can get free courses. So good. And now you check the property has nones, has not numbers, and you store this in the result, and the result is true. Okay, so if you run this code, let's check if the result is truly true. Yeah, you see the result is true. So how does this happen? Yeah, so basically this has nones. It's just an attribute that stores, if you initialize a series, it stores in this attribute whether the series contains a not a number. And it contains one, so therefore the result is true. So this is how you can check a series if it contains a not a number value. So when filtering a series, let's have a look at another example. When filtering a series with var, and no element passes the filtering condition, what is the result? So this is what we are going to explore next. Again, I copy paste code, we import Pandas, we create a series object. You have already seen this, a series with 5 values, and all values are non-nuns. So all values are real values, numerical values. But now you use the NumPy function var, and you filter these XS, so the series is larger than 2. This uses broadcasting operation to check element-wise whether each element is larger than 2. And so this is a filtering condition, and you set in place to true, which means that you overwrite the values in XS. You can also print XS to see the whole series, how it looks. And now you check, does the series has not a numbers, and the result is true. So it contains, initially it doesn't contain not a numbers, but now it contains not a numbers. Why is that? Yeah, because you use as criteria, you use XS is larger than 2. So sometimes this is the case, like here. Sometimes this is not the case, like here. So the second value, each time it is not the case, not a number, is placed into the series. Okay, so this is very interesting because now, so it simply takes the where condition, it checks for each element whether it matches the condition, whether it should be filtered or not. And if not, then it is replaced by not a number. So all basically after applying the where operation, you get an array or a series that contains only the numbers that pass that filter, and all other not a number values didn't pass the filter. And now you can use this follow-up operation to remove all not a number operations. You will see how this works out later, how we can remove all not a numbers from a series object. But you should just know how the where operation works, and this is how. Good, so let's have a look at another example. What if you work with multiple series of different length? So let's have another code example. Again, we import pandas, we create two series. One series is called S, the other series is called T. And you see, when initializing this series, the first series has 10 elements. The second series has 20 elements. So it goes from 0 to 19 included. So it is different length. And now you do element-wise addition on those series objects. So you add together those series and you access, say, the first value. And let's run this function, check whether the result is really 2. Yes, it's 2.0 actually. And but what happens if we print s plus t? Let's do it again. Now I need to get. Okay, so this happens if you print s plus t. So for the first 10 elements, you actually get the addition, yeah? So you add together 0 plus 0, 1 plus 1, 2 plus 2, and the result is a float. So you have 0, 2, 4, 6, 8, 10, and so on. But then but now the second series T is the only one that has a value, and the first series S for all elements with index from 10 onwards, only series T has values, series S doesn't have any values, so therefore you add together not a value with a value, and the result is not a number. Yeah, so if you add a certain integer value or a certain numerical value to a value that doesn't exist, then it's not a number. So it makes sense. Many people would assume that it just assumes 0 if there is not a number in one series, but this would cause many problems, many bugs, and you will never find those bugs, because then it would assume that both series have some values. Maybe 0 has a meaning, so you cannot just initialize the values that are not there with 0, because then in many cases there would be some values that superficially make sense, but if you dive deep, they don't make a lot of sense, because you have assumed that they should be initialized with 0. So actually it's much more clean to just throw the error implicitly by adding this not a number value. So one number that doesn't exist added to a number that does exist is not 0 plus a number that exists. It's not a number. So therefore it makes sense, yeah? This is how not a number values arise in your data very often. Good, let's have a look at another example. How to create a data frame from a list of dictionaries with unequal keys. And now this is the key information here. So say you have a list of dictionaries like here. So we have 3 dictionaries, and dictionary maps keys to values. And you see you have similar keys. The car key is available in all 3 dictionaries, but then you have a driver key that is not available for all dictionaries, like this, yeah? So what happens now? Now you can use the data frame constructor, pass the data, the list of dictionary, and use some indexing mechanism here. So rename the indices of this, and you sort the indices, and you print the result. So and the result is Ferrari. So what is now the special thing? Let's have a look how the dictionary actually looks. Print df. After sorting. Now you can see here we have not a number value, because Lamborghini here has not a value for driver. So the driver column for the third row, this Lamborghini row, the driver column is not a number. Why? Because we have not, in the dictionary, doesn't contain this data. So you can create a data frame from a list of dictionaries, but if it doesn't contain a value, so if a value is missing, then it is replaced by not a number. And this is like a very general rule of thumb that happens a lot with Pandas DataFrames, that missing values are just replaced with not a number. Missing values are not replaced with zeros or minus ones or all this, because this is very bad style to create like dummy values, to fill it with dummy values that actually could have a meaning in your data. So I mean, if you have, say, if you have a machine learning model and you train it with some prediction algorithm of a future stock price, and then you have some days where you don't have any data, and now you would initialize this data with 0 or with -1, then the prediction algorithm wouldn't make sense anymore. It would actually, this data, if you initialize it with some numerical dummy data, it would just cause the machine learning algorithm to fail and to produce unmeaningful results. And therefore it's much better to initialize them with not a number, to make it explicit that we don't have any information here, and not filling it with some dummy information. Okay, and this is done very nicely by Pandas in very different approaches. But in general, if you have missing data, it is replaced with not a numbers. Okay, so what happens if we sort a data frame that contains not a numbers? And I will not actually execute this, maybe just have a look at this example. So we read the data frame from a file, say cast.csv, and now we have some column names and some row indices, and we have some values for our columns. And now one column like engine size contains not a number. And now we sort the column. Here we call data frame sort values. So on this data frame we sort the values and we sort by engine size. Here, this is the column by which we sort. So now the not a number value here is basically moved to the end from the Python sorting mechanism. So implicitly Pandas assumes that not a number is the maximum value, like infinity value or so, and it doesn't assume it is a minimum value. So it is moved to the end, it is pushed down to the end if you sort it. And sorting by default is in ascending order, so we have like this one would be the first element, this would be the second element, this the second, and so on. And this one would be the last element. So not a number, if you use in sorting, it is pushed to the end. Not a number is assumed to be the biggest value in the data frame. Now another related question is, how can you count not a number values? Not sort not a number values, but simply count them in a column. So say you have the following data frame. Again, you read it from a file, from a CSV file, and it looks like this. Now we want to count not a number values, and here we call df count, and the result is we count not a number values. Sorry, so we count all rows, number of rows that are not not a number values. Okay, so in this case we have 4 rows, those 2 rows and those 2 rows that are not a number, and this row is simply then so if you call count on a data frame or on a certain row, like here on the 5th row, then it is simply ignored. So not a number values, rows, columns that contain not a number values are ignored by the count method. Okay, next, how can we drop not a number values? Let's replace this. So you see, it's a good training to go over those examples quickly, to see multiple data frames in sequence, so that you over time build your understanding. Even if you don't understand each and every detail, it still makes sense to try to follow and try to see different code snippets programmed by some professional coders. And good, so here again we have the same data frame, and now we want to drop not a number data frames, and this is used by the function drop not a number. Okay, so drop now actually drops all not a number rows, and here you can focus on, say, the price, and then it wouldn't drop any. Yeah, so this here in this case, if you specify subset price, then it wouldn't drop any, but if you don't specify it, then it would drop not a number, and therefore those have different length. Okay, so for example, selection 1, where you have specified subset price and you have price data for all rows, then the result would be 5. So the first result is 5, and the second result is 4, because it simply checks whether one row contains not a number, and if this is the case, then it simply drops it, and therefore it has only 4 rows, this second selection, or selection 2. Okay, this is how you can drop not a number values. And then another question is, how can we concatenate dissimilar data frames that are filled with not a numbers? So now it's getting a bit complicated, but still it makes sense to have a look at those examples. So say we have 2 CSV files, cars and cars2. We read one CSV file in the data frame df and the second one in data frame df2. And now you see that these are dissimilar data frames. They have dissimilar columns. They are kind of the same. They both have the column like make, and the column origin is only available here in data frame 2. But here data frame 1 also has a make column, but doesn't have an origin column. And now we simply call this result concatenation, this concat function, on these 2 data frames, and yeah, the result is y. So we can also print. I cannot print it because I don't have the files here available, but this is how they would look like, and you can call the concatenation operation. And yeah, missing values in the rows are simply filled with not a numbers. So if you have missing values in some rows, then they are filled with not a number. So now we have, for example, both have make. So make rows will all be filled, make columns in some rows. But now you have, for example, Ford aspiration. You don't have any information for Ford aspiration or Ford full. You don't have any information for this, and those will be filled with not a numbers. Good, and this is also how you can do the merging or joining. If you know SQL, you know how to join different tables. You can join tables and you can merge tables. You can do an outer join, outer merge. And what happens if you have missing values? Missing values are always replaced with not a number. And this is really the rule of thumb. The one takeaway you should get from this video: missing numbers are replaced with not a number, and not a number is not equal to like 0 or -1 or any dummy value. You shouldn't do this. And now what happens if you have a data frame with not a numbers in it? Let's have a look at a simpler example. So now you have such a data frame, and this has a not a number value. How can we replace it with the dummy value? So if we actually want to replace all not a number values with dummy values, we can do this by using the Finxter function. Fill not a number, so and we give the default value, and we can specify in place whether we want to change this existing data frame or create a new one. If we set in place to true, we basically exchange this existing one. And this simply replaces all not a numbers with the initialized data with the initialized data value you specify. Okay, so I think that's enough for today's video. If you want to improve your data science skills, then check out our free email academy. Also, if you like to read books, then check out book Coffee Break NumPy. And stay tuned, because we are going to release Coffee Break Pandas soon. And yeah, thanks for watching this video. I hope you learned something out of it, and see you in the next video. Bye.